Okay, 4.3 is Triangle Congruence by ASA and AAS. So there are 4 shortcuts that have 3 letters. What were the first 2 we did? SSS, SAS. Today, we're doing ASA and AAS. And the thing about today is if you look at your letters, it's the same number of each letter, but they are different. So ASA has 2 angles and a side. AAS also has 2 angles and a side. They're very different. Okay, so you need to really be careful which one you're choosing today, because you might think it's one and it's actually the other. All right, so here we go. Angle side angle, also known as ASA, says this: if 2 angles, sorry about my G, and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. And there is a word, it's in here twice, that should stand out in how you decipher between ASA and AAS. Any guesses what that word is?
Side.
It's not side. And it's not angles.
Included.
It's included. Do you remember what included meant? It was the one that fell between, right? So like in this picture, AB is the included side between these 2 angles. So those 2 angles meet at AB. Okay, that is the included side. If you look at like this side, for instance, that is not touching angle A at all. So it is not an included side. Okay, so it has to be the included side that you're using on these for this to work out. So we would say triangle ABC is congruent to triangle DEF. Remember, we're still matching up corresponding parts by angle, side, angle, because that side falls between the 2 angles. Okay, so the side in the middle. So look at this picture. Example 1. Which triangles would be congruent by ASA? 1, 2, 3. Which triangles? 1 and 2 are the ones that are congruent. Why not number 3?
Oh, because
It's not included, right? The included side would be this one, and they didn't give us that one. So we know it's not that triangle. But now here's the other tricky part, is you have to match up the corresponding sides. So I would say triangle, if I say UVS for the first one, then what triangle do I have to say for the second? EON. So I went 1 arc, 2 arcs, no arc. So I need to go 1 arc, 2 arcs, no arc. So EON. Okay, and that would be by angle, side, angle. Okay, questions on that? Okay. Example 2 here. This one's a proof. I know those triangles don't look like right triangles. It's the error of my drawing. You know I'm not an artist at this point. In this proof, what is your step 1? Given. Always. Please don't get that wrong. It really makes me want to cry when people don't get the given. I know I don't want to cry, but I just do if it happens. So all of this is going here. Okay. We said for ASA to work out, you need to prove 2 sides or 2 angles congruent and their included side congruent. Well, if you look, we have these in the given and these in the given are marked congruent. B and E are not marked congruent yet. So that's actually the only step of this proof that you need to do before you can say the triangles are congruent. We know that B is congruent to E, which is what we're going to say here. Angle B is congruent to angle E. But why do we know that? they're right angles, right? And we know that all right angles are congruent. That was a theorem we did last chapter. It just said all right angles are congruent. Do you remember that? That's all you have to say. We know that all right angles are congruent. Okay? So now if you look at your markings, you have an angle, a side, and an angle with an angle, a side, and an angle, right? So we can say what they asked us to prove. Triangle ABC is congruent to triangle AED by angle, side, angle. Okay? Questions on that? That one's pretty straightforward, not a lot of fancy stuff going on there. Okay, the second shortcut, which is actually our fourth shortcut now, is angle side, or AAS. And this one says, if two what? What do we have two of in this one? Angles. If two angles and the non-included side of one triangle are congruent to two angles, and I left a word out here that is very important. Right here, you need to write the corresponding non-included side of another triangle. So if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. What do I mean by the corresponding non-included side? Yeah, Grace.
The other side that isn't revealed.
Yes, but the one that matches up with our first one, right? So we're looking for instance, if this one goes angle, angle, side, and it goes single arc, double arc, side, you cannot go double arc, single arc, side, because this one's not included either, right? It's not the included angle, but it wouldn't make these congruent because it's not the corresponding non-included side. It has to be the one that matches up with the other triangle. Does that make sense? So in this case, single arc, double arc side is what we're looking at. So we would say triangle ABC is congruent to triangle DEF by angle, angle, side, okay? Here's the beauty of ASA and AAS. So we could have done this in the last theorem too, every time. You have two angles here that are congruent to two angles here. So what else do we know about these two triangles is the same? The third angle, right? The third angles theorem, because we could use it here, it could actually lead us to ASA, because we would know that these two angles are congruent. So you could say this is ASA. Does that make sense? Okay. So just keep in mind, it can be ASA or AAS. If you do the ASA route, it's an extra step, okay? All right, proof. First step here is our what? The given. Okay, you would just take this information and plop it in here. But that information is meant to lead you to something. Impress me, make me happy right now. What do you see in there that you know is going to show up? Parallel lines lead to what? AIA. Oh, I love you. You make me so happy. Okay, so when you see parallel lines, you're looking for alternate interior angles like 97% of the time. It will be AIA when you see parallel lines, okay? So in this case, we have parallel lines. That means, can you tell me which two angles? Be careful, because only one set of lines is parallel. You can't say W and R though, because there's multiple angles there.
One W and one R.
What?
Oh, he's smart. Oh.
M and K is already marked congruent. MRW would not work because that would mean the top and bottom are parallel. Okay, look at it this way, guys. You have these two lines with this transversal, right? If these are our parallel lines, then these are our congruent angles. Do you see it? How do you say it? That's what I'll show you right now.
Why can't it be the other side?
Because they didn't tell us that these lines are parallel, right? That would be those two angles. But they didn't tell us those lines. Okay? Okay, so what we need to say is that angle KRW is congruent to angle, so KRW is congruent to MWR. And why was that again? Alternate interior angles. Okay? Now remember, we're trying to get to ASA or AAS or SSS or SAS. Look at what we know so far. We know two angles. So it's probably not SSS or SAS because we already have two angles. All we really need is a side. Do you see a side that we can say is congruent to a side on the other triangle?
Yeah, I do.
What?
E is congruent.
WR, right? This side right here, WR, is congruent to WR. What is that?
Reflexive.
It's reflexive. You guys, reflexive is going to show up all over the place. Look for it, okay? If you're not sure, look for reflexive, look for vertical angles. They show up a ton, okay? Now look at your markings. This is why I say it's so important to mark it. What do you see?
Well, I was just gonna say, can't you say that they're congruent?
You could say that the third angles there are congruent by third angles. It just doesn't help you at all. It doesn't get you any closer to saying the triangles are congruent because this is a great segue. There is no AAA theorem, right? We did SSS, SAS, ASA, AAS. There's no AAA. If you have two triangles, say these are congruent, those are congruent, and these are congruent, right? Those are not congruent triangles, even though all their angles are congruent. So AAA does not get you congruent triangles, okay? So it's a good thought. It just doesn't get you closer to the final thought, right? What do you see in your markings right now? Angle, angle, side. Is it AAS or ASA? It's not the included, right? AAS. So it'd be triangle, what they asked you to prove, WMR, congruent to triangle RKW by angle, angle, side. Okay? Questions on that? Yeah.
You said it could also be third angle theorem. Does that apply to this one?
You could use third angles theorem here. It just doesn't help you prove that the triangles are congruent, right? So there's no need to use it because it doesn't get you any closer to saying triangle this is congruent to triangle that.
So then what's the difference between
AAS, okay, here's a great point for all of you. If you're using SSS, SAS, ASA, or AAS, the only reason that can be for is if you're proving triangles are congruent. So if you see this in a proof, triangle something congruent to triangle something, it is going to be one of your three-letter theorems. Third angles theorem, it would come from if you're proving angle something congruent to angle something, right? So that's a great point. Triangles congruent is always a three-letter theorem. There will be a two-letter coming, but for now it's always a three-letter theorem, okay? Okay, last one. Are those two triangles congruent?
Yes. No.
Who thinks yes they are? Who thinks no they're not? And a lot of you don't have opinions.
I don't have an opinion.
Okay. I saw a whole lot of nots, so why not?
Because you don't have
Because
the,
not.
you don't have the included.
Because
total.
F and I aren't equal to O.
Okay, but it doesn't have to be the included, right? Yeah.
R and I mean F and I is
Him,
like
him and Locke.
congruent to
Actually,
OG.
no.
It's not though. They didn't mark it congruent, right? But it would have to be for this to be congruent. Is that what you're saying? Yes. So you have these two angles match up, excuse me, with these two angles. If those two angles match up, then you have to look at your side. This one would be double arc, single arc side, right? Let's just get rid of the highlighter. AAS, right? This is AAS, but in a different order. It's single arc, double arc side. You cannot do that. It has to be the corresponding side that is not included, okay? So the answer would be no, because it's not the corresponding non-included side. Okay? Questions on that? All right.